Right, so today we talk about frames, not Gatorade. Okay, so frames is very important because it will help us when we do motion programming for the robot. Okay, there are three types of frames that we can use for the final robot. So there's world frame, which is the default frame of the robot, and then the tool frame, it's a user-defined frame, and then you have the user frame. There is another one which we call as the jog frame, which we will discuss after we have set up both the tool frame and the user frame. So what's a frame?
A reference?
So a frame is the reference. It's a plane which are intersecting in right angles. So here we have the intersection of the X and Y and Z planes. Okay. So the X direction is forward and backward direction. The Y axis represents the side-to-side movement, and the Z axis represent the up and down motion of the robot. So the origin of the final robot is located with the intersection of the Z-axis of joint 1 and the Y-axis of joint 2. That is the origin of the final robot. So you could also specify another frame, and that is where we will teach the robot based on user frame, and you could specify another frame with another origin. So here is another frame which you can teach the robot. So the frame is based on a two-dimensional Cartesian coordinate. Okay? So it's a rectangular coordinate system. So we have the X-axis, the horizontal axis, and the Y-axis, the vertical axis. It's an ordered pair, X and Y. So if we provide the value of X and the value of Y, we can determine the position of an object in the Cartesian coordinate. So for example, you have X equals 600 and Y equals 800. Then you have this position here. That is the two-dimensional Cartesian coordinate system. Do you have any question? So now we try to lay flat that plane of X and Y axis, and we extend the two-dimensional axis to 3 dimensions. So we add the Z axis here, and again the Y axis represents the front and back motion. Y axis is the side-to-side movement, and the Z axis is up and down movement of the robot. So this is an example. If you have given X is 600, so that's forward, Y 800, that's positive Y, and then down 700, it's negative 700, so that's the position of the point in 3-dimensional Cartesian coordinate system. So when we jog the robot, there are 3 different jogging modes that we can do. Okay? First, we'll talk about jogging in world mode. Okay, so there's also jogging in joint mode. And there's also jogging in user and tool. Okay? So now we go back here. We jog in world mode. There are two axes. One is the major axis and the other one is the minor axis. The major axis provides the position of the tool point. So the end of arm tooling of the robot, that's the position. And the minor axis is the rotation. So it is represented by yaw, pitch, and roll. Yaw is the rotation around X, pitch, rotation around Y, and roll is the rotation around Z. So let us try to move. Can you try to move the robot in the world? How do you go to the world mode? Okay. So does it say world mode there? Okay. And you give me negative Z. So how do you get out of singularity? When you go back in world mode and demonstrate motion in negative Z. How about positive Y? X. You see the X, front and back, and then Y side to side, Z goes up and down. And that's the position. So can you demonstrate the minor axis? A yaw, pitch, and roll, the yaw. So it's rotating with respect to the Y or X axis. The yaw is rotating around the X axis. And then the pitch rotates around the Y axis, and the roll, where's the roll? Roll rotates around the Z axis. Okay, so that is orientation in world mode. So we have seen this. This is rotation around X, that's the yaw. And then this is the rotation around, what axis is it rotating in?
Y.
Y. So it's rotating about Z. Okay, so that's the roll. And then by pressing the position menu, it will give us the position of the robot, X, Y, and Z, the three positions, and the yaw, pitch, and roll. And also, you could also change it if you want to see based on user frame and joint frame. So you could see the position by, so let us try to demonstrate what is the current position.
X is 552, Y is 828, Z is 96.
How about the yaw, pitch, and roll?
Y is negative 178, which is negative 29.
Can you make the yaw 0? That's 0. It's negative 90. Or do you think it's 0? How about the pitch? And roll. Is that 0? So the 0 in yaw is if it's facing the other. Okay, so like what I have discussed a while ago, there are this word frame, tool frame, and user frame that we need to understand in order to successfully program the motion of the robot. See, the word frame, the origin of the word frame is the z-axis of J1 and the intersection between J1 and J2. That is the position of the origin of the word frame. So if you have not specified any user frame, the default user frame is the word frame. So the motion of the robot is based on this default user frame, which is the word frame. The word frame is based on the right hand rule. So if you are standing at the back of the robot and do the right hand rule, so this is your, what is this axis here?
X.
That is the positive X. This one is, and that is the positive Z. So that is the right hand rule.